So now that we understand some of these translations, uh, let's look at one of these examples. So the first example says we have g of x equals x plus 2 squared minus 4. And what we want to do here, we are going to, our instructions are going to be to describe the translation and we're going to graph it as well, and graph the function. Okay, so the first thing we want to do is understand what translations are happening here. So if we look inside of this squared term, we have x plus 2 squared. Okay, so this is going to be an example. If we go back to those translations, this is going to be an example of adding something to x. We're adding something to x inside of this squared term here, and so this means we're going to have a shift that is 2 units to the left. Okay, so it's going to shift 2 units to the left because it's x plus 2. Another way you can think about this is just kind of ask yourself, well, what makes that term 0? Which x value would zero out that squared term? Well, negative 2, right? So it's going to go 2 units to the left. And then if we look at the minus 4 right here, that is going to be that's going to be a shift down 4 units, right? That's our k value. If we go back here, this is minus k, so that's going to be k units down. So this is going to be a shift that is 4 units down, right? And so we want to be able to look at the function and describe what is going to be happening in comparison to the parent function. I'm going to put the parent function over here. The parent function, let's just say here is just x squared. If we think about the most basic quadratic function, it's going to be x squared. Compared to this parent function, this function is going to move to the left and it's going to move down. Now what we want to do, now that we described it, is let's graph each of those functions. So I'm going to have a graph here, and I'm going to graph both things. I'm going to graph the parent function, and I'm going to graph the translated function. So let's start here. I'm going to put a few notches here, and let's graph the parent function, which is going to be x squared. So if I graph x squared, well, that's going to be 0, 0. If I plug in 1, I get 1. If I plug in 2, I get 4. If I plug in 3, I get 9, 5, 6, 7, 8, 9. It's like way up here. And I'm going to sketch this parent function here. Negative 1 gives me 1. Negative 2 gives me 4. Negative 3 gives me 9. And you should be able to sketch a quadratic function there. So there's the parent function. Now if we take and follow these rules to graph the new function, we're going to take all the points, right? We're going to take the points and we're going to shift them to the left 2 units, and we're going to shift it down 4 units. So if you want to, we can really just, instead of being super precise here, we're just doing sketches. So we can really just focus on, let's just say the vertex right there. Let's just take the vertex, and we're going to shift this point to the left. So it's going to go, let me take this point right here. I'm talking about this one right here. It's going to move to the left 2, and then it's going to move down 4. So left 2, down 1, 2, 3, 4. It's going to go right here. So it's going to move to that location. Okay, so now my sketch is still going to have the same shape, and I'm not going to pick points, make a table, and give some sort of precise graph here, I'm just going to sketch it, right? So I'm going to give my new graph, and I'm just going to say, I'm just going to sketch the same parabola there. Okay, so my new graph is in blue. My old graph, or the parent function, is in pink. Okay, so the vertex has moved to the left 2 and down 4. Let's try another one of those really quick. Let's say we have a function f of x, or let's call it g of x. G of x, and let's do an absolute value function. So let's say we have absolute value of x, and we won't have any addition or subtraction in the problem. And let's say we have plus, I don't know, 3 there. Okay, so remember, this is an absolute value function. So if we're thinking about the parent function is going to be f of x equals just the absolute value of x. So we're going to think about what transformations are happening here. Well, if we look inside where x is, right here, okay, we're not adding or subtracting anything directly to that x inside of that absolute value. So there's going to be no horizontal shift. So we're going to write here, there's going to be no horizontal shift. And if we look at the plus 3, right, that's going to be a vertical shift. Everything's going to move up, right? So we do have a shift 3 units up. So that's going to be the comparison here. So if I wanted to graph this one, right, I'm going to graph the parent function, and again, not going to keep it, you don't have to make a table of values, you don't have to make it incredibly precise, because we're kind of just sketching these translations at this point. The parent function would just be, remember it has a vertex, it's at 0, 0, and then it goes off to the right, and it goes off to the left. So there's my parent function. And if you're doing this in pencil, and you're going to make 2 graphs like I'm doing here, a good thing to do here is just to make it light. Just maybe sketch it lighter, and then put your final graph in, just darken that final graph. Right, so what we're doing here is we're taking this graph here, okay, or you can just think about the vertex moving. We're taking this graph, and we're not moving it left or right. We are simply moving it up 3. So I'm going to go 1, 2, 3, and that is going to be my new graph. And so I can say this is g of x, and I can put in here that this is, going to be 3. 1, 2, like that y value is going to be 3 here for this is g of x. And I can think about this parent function down here as being f of x. So what I want to see on these is describe that translation, and if you have to graph it, you would graph the function, graph the parent function lightly, and then show how the new function looks compared to the parent function.